Students, and welcome to today's lesson. I'm Miss Lee. Today we will begin to investigate the question, why do some animals live in groups? Are you ready? Grab your pencil and your science journal and let's get started. After our last lesson, I just couldn't stop thinking about Amos and Boris. I actually reread the whole book. The story got me thinking about what we had learned about environments and suitability, about how for a whale, some environments are more suitable than others because of the whale's characteristics. We learned a lot last time, and it is definitely time to make another entry on our anchor chart. Based on what we learned last time, we can add that for any particular environment, some kinds of organisms can survive well, some can survive less well, and some cannot survive at all. Awesome. Now let's check out another animal that lives in a cold environment. Ready? Look at these animals. These are emperor penguins. Have you ever seen penguins at a zoo or an aquarium? I will play a video clip of these penguins, and I want you to pay close attention as you watch. What do you notice about the penguins? What do you wonder about the penguins' behavior? Ready? Wasn't that great? So what did you notice? I noticed that there are a lot of penguins. I also saw that most of the penguins are standing very close together, but some are standing a little outside the group. And I noticed that the penguins look like they are standing on ice or snow. Did any of your observations lead to questions? What do you wonder? Well, I wonder why the penguins huddle in a group. Let's watch the video again. This time, ask yourself, why do you think penguins behave this way, and what makes you think that? So what do you think? I think the penguins may huddle to stay warm. It looks really cold where they are. What do you think? Do you agree that penguins may huddle in groups to stay warm? I know I enjoy a nice warm hug when I am cold. How can we test our idea? We can't bring penguins into our classroom or our homes, but we can create a model of penguin behavior. And we can also use the model to test our thinking. Scientists often use models to test their ideas when real-life tests aren't possible. Here's a model we can test. I have 8 test tubes. Each test tube represents a penguin in our model. Now we are testing whether penguins huddle in a group to stay warm, so we need an ice-cold environment for our model penguins. We'll use these containers filled with ice to represent the icy environment where the penguins live. And we'll use a thermometer to measure temperature. Now, if you use these test tubes and thermometers at school, remember, they are made of glass, which can break and cause injury. Handle the test tubes and thermometers with care. Never throw them or tap them on any surface. If a test tube or thermometer breaks, then alert an adult immediately and do not touch the broken pieces. Okay, let's begin. Right now, we think penguins probably huddle in groups to stay warm. Which penguin in the huddle do you think is the warmest? I think it'll be the one in the middle. Do you agree? When we watched the video clip, we also saw some penguins by themselves, away from the group. Let's make sure we investigate both a penguin huddled in a group and a penguin alone. In our model, we'll use a single test tube by itself to represent the lone penguin, and we'll bundle a group of test tubes together with a rubber band to represent the penguin group. The test tube in the middle of the bundle represents the penguin in the middle of the huddle. Now, how can we use our model to determine whether the penguin in the middle of the huddle stays warmer than the penguin on its own? We can use the thermometer to measure the temperature of the test tubes. We will measure the temperature of the single test tube, which represents a lone penguin, and we will measure the temperature of the test tube in the center of the bundle, which represents a penguin in the middle of a huddle. Before we begin, we'll measure the starting temperature inside both the lone tube and the bundle tube. And after we place the tubes in ice, we'll wait 5 minutes and then measure their temperature again. Can you make a prediction? What do you think will happen to the temperature inside the test tubes? Which test tube will be colder at the end of our investigation? The single test tube or the test tube in the middle of the group? Hold on to those ideas. Let's investigate. First, I will measure the temperature inside the single test tube, which represents the lone penguin, before I put it in ice. Here is the starting temperature inside the single test tube. Let's pause to make sure we know how to read a thermometer, the tool we use to measure temperature. I see the tick mark for 60 degrees and the tick mark for 80 degrees, but looks like some of the numbers in between are missing. I'll fill them in now. I will label 70 degrees, 72 degrees, 74 degrees, 76 degrees, 78 degrees, and 80 degrees. The top of the center black line stops between 74 and 76 degrees. So I will record starting temperature inside the single test tube of 75 degrees Fahrenheit. Okay, now I'll measure the temperature inside the bundle test tube, which represents the huddled penguin, before I put the bundle in ice. It's a little hard to see with all of those other test tubes in the way. Let's zoom in. We're using the same type of thermometer, so we'll read it the same way. The line is a little above the mark for 74 degrees, but it's definitely below the mark for 76 degrees. So I will record a starting temperature inside the bundle test tube of 75 degrees Fahrenheit. Now that we have our starting temperatures, I'll put the single test tube in the ice. Here's a time-lapse video of single test tube sitting in the ice for 5 minutes. If you look closely, you can see the line of the thermometer moving down. Let's check the temperature now. Wow, the temperature changed a lot. The temperature inside the test tube started at 75 degrees. But after the test tube spent 5 minutes in the ice, the temperature dropped to just 40 degrees Fahrenheit. Did you expect that? Well, I'll record the measurement in the chart and we'll repeat the procedure with the bundle test tube. Here's the time-lapse video of the bundle test tube sitting in the ice for 5 minutes. Remember, the temperature inside this test tube also started at 75 degrees Fahrenheit. Let's see how much it changed. The temperature inside the bundle test tube now, after 5 minutes in the ice, is 48 degrees Fahrenheit. Interesting. Did you expect that outcome? Well, let's examine all the data we collected. What do you notice about the temperature inside the test tubes before and after I placed them in ice? I noticed that the temperatures of the test tubes were the same at the beginning, but they were different at the end. I also noticed that after the test tubes sat in ice for 5 minutes, the temperature inside the bundled test tubes was higher than the temperature inside the single test tube. What does that mean? It means that in this icy environment, the test tube in the middle of the bundle stayed warmer than the test tube on its own. How does our model relate to the behavior of the penguins? Our model shows that the penguins standing by themselves must be colder than the penguins in the middle of the group. Penguins stay warmer when they group together than when they are alone. Now we have evidence to make the claim that penguins huddle in a group to stay warm during the winter. But penguins are the only animals that live in groups, and not all animals that live in groups live in cold environments. So they might have other reasons to group together. I wonder, what are some other reasons that animals may live in groups? Your task after this lesson will be to answer this question. In our next few lessons, we'll learn about other animals that live in groups and we'll explore the reasons. Let's review your task for today. First, fill in the blanks to update the anchor chart. Second, answer the questions about the reasons other animals may live in groups.